work on creating quadratic models, and specifically you're going to be using factored form. We'll do a very similar example with vertex form, which you guys have learned before also. What we're going to do is we're going to try to give an equation to the McDonald's arches. Okay? So, specifically, I'm going to use the arch at the bottom here. I know that's not so greatly outlined, but we're going to use these two bottom ones, and I'm going to tell you why. Okay? The reason we're going to use these is because I want to do an example with factored form. Okay? And with factored form, we need to find the x-intercepts. So, the reason we're using the archers underneath is because these two actually go through whole numbers. Let's go on the assumption that each of these is 1, 2, 3, going up by 1, a scale of 1 on the x and the y-axis. What that means is, and there are two different parabolas here, we can use this information to help solve our factored form. So, for instance, 1, 2, this coordinate is a value of 0. Nope, not 0. 2 and 0. And this one here is at 3, 4, 5, 6, 7. So 7 and 0. And our other one is at negative 1 and 0. 2, 3, 4, 5, 6. Negative 6 and 0. Okay? So, we're going to focus on the one on the right first, and we're going to create a quadratic model with this. So we have this information. We have these x-intercepts. Okay? With these x-intercepts, what we're going to do is we're going to take those values, and we're going to plug them into our quadratic model. Now, R and S stand for what, usually? The zeros. And the zeros are our x-intercepts in this question. So our x-intercepts are 2 and 0. And 7 and 0, which means I can call either R or the other one S. So here's our R and our S. So we're going to plug them in. We have f at x is equal to, do we know the a value? No, we still don't know the a value. We do know it's negative, good, because it is opening downwards. And we have x minus positive 2 and x minus positive 7. Okay? I specifically said it that way because we're going to do the other examples that show you how that changes a little. So what we have now is we have a good chunk of this formula already created. The only variable we really need to finish this out with is our a variable. Now this is very difficult to figure out from here. So what we're going to do is find another coordinate, one that it looks like it passes through perfectly, and this is probably a good value right here. This one's at 6 and 1, 2, 3, 4, 5. We're going on the assumption that is roughly 6 and 5. The reason I need another coordinate along here is because I have too many variables right now. Okay? This is our, you could say, y-axis on this graph. These represent our x, and we don't know a. That's 3 unknowns. But these numbers both represent an example of an x and a y. We're going to plug those values in for the x and y in this question. So since this is essentially our y, the f at x, we're going to replace f at x with the value of 5, and I don't technically need brackets, but we'll put it there, is equal to our a, and our x value, which is 6, we're going to replace x with 6 in both of these. So 6 minus 2, and again 6 minus 7. Okay. From here, we now have only one variable, a. So we can solve for our a and then plug that value into what we started with. So we have 5 is equal to a. 6 minus 2 is 4. 6 minus 7 is negative 1. Bringing it 5 is equal to negative 4a. And when we bring 4 over, we're going to get a is equal to negative 5 over 4. Yes. Okay? Our a value is what? What's the operation there? It's negative, right? And does that make sense with our arch? Do we need a negative value? Yeah, it's facing downwards. So the equation of the very first arch we've made is f at x is equal to negative 5 over 4, x minus 2, and x minus 7. Okay? So we've just created the model for the parabola in factored form. Now, we are going to do the other one. The other one here, I want to do it because we have some negative values. Yeah. So, factored form again. We'll call this the second parabola here. Again, we're going to have f at x. I'm just going to use blue this time. We have a, x minus r, x minus s. What are our r and s for these, or this parabola? Yep. -6 and -1 are going to be our r and s. So when we go to plug these values in, f at x is equal to a, x subtract -6, and x subtract -1. Okay? And what ends up happening is we get a is equal to x plus 6 and x plus 1. So this should give you an idea why now we end up with opposite operations. Because our equation is a negative, when we plug negative values in, we end up with positives in here. And vice versa, when we plug positive values in, we end up with negatives. And that's why we get that opposite relationship. So, with that being said, we now know the only thing we really need to do next is find another coordinate on here to help us find our a. So we look for a value that's easy to use, okay? And this looks like another one that'd be really easy to use. Now, technically, I could use this coordinate or even the vertex in this one. But the problem is they all look like they're probably going to be decimal numbers that I'm going to have to estimate. Yeah, I got you. So, with this value here, this looks like it's at -2 and 4. Okay? So -2 and 4 is going to be the value that we use. Our y will be 4. And our x's will be -2. So when we plug them in, we're going to get 4 is equal to a, -2 plus 6, -2 plus 1. 4 is equal to a times 4 times -1. Hey, this one's even better. We're going to get -4a is equal to 4, which means a is equal to what value? 1. Not just 1, but -1. We divide by -4. So, in this case, our function is f at x is equal to -4, x plus 6, and x plus 1. Now, let's use some logic here. Here's one of our answers. And our other answer was here. Zoom out. Okay. What did you guys notice about our a values? They're not quite the same. They're slightly different. Not by a large amount, but just by a little. One is 1 1/4, and the other one is just the value of 1. Would you make the assumption that McDonald's probably had identical arches made? Yeah. Probably. So there's probably an error on our part because we had to do a bit of estimating with that other coordinate. And that's what's going to happen. We're going to create a parabola that's very, very similar, but maybe not exact to what the model will be. We're trying to get as close as possible to what they are. Okay? Both of these would be good, educated guesses for what the models of the parabolas would be. Okay? And what we'll do is we'll use vertex form for another one. Yeah.